Hi there, and welcome back to another video on post-processing with ParaView. So in this case, we're going to focus more into the quantitative aspect of ParaView. So we're going to see how to do this kind of plots. Look at that, we're taking a signal, we're computing the frequencies, we have access to table data, we can plot, and as you look here, these are the residuals. Then also we can cross-reference this data with your instantaneous solutions, average solutions, what we can take from average values, when we can assess that or say that the solution has been converged by looking at this data. But the important thing is that we are going to focus in this kind of computing quantities, integrals. You see here now this workflow that might look like a little bit complex at the beginning. We hope that we're going to demystify everything. And this is probably the most important now new filter, FFT, doing signal processing inside OpenFOAM and inside ParaView. And also getting these tables, you can also save these tables in external format and so on, or read file from OpenFOAM, like in this case. So this will be our focus. We're going to run the classical cylinder simulation. I'm going to show you, the execution right now. You should have the link in the video description to download the case. It's ready to go. All this post-processing that we're going to do with ParaView is done with ParaView 6. Okay, I want to stress this because some of the filters that we're going to use, they are not available in older versions. Okay, probably in 5.13 you will have it, but in 5.11 or 12 you don't have it. So please, you can download ParaView, install in your computer, and that's it. You don't need to recompile OpenFOAM, nothing. You can use it, open the case in the usual way. So as usual, I would like to, now doing all cases, I run from scratch, and then now I show everything on the screen. So I will do that. So to mention our classical cylinder case, I think I don't need to stress anything here in particular. ParaView, you will have some steps that we're going to go through, okay, to do all this post-processing in ParaView. Numerics, standard numerics. We're going to use also in the script set fields to add that initial perturbation to accelerate the onset of the instability. And you have two scripts. It's up to you to run in serial and parallel. Okay, in this case I will run here in parallel. Two cores here, so depending on your computer, if you want to use more, put it there, and automatically will change all the scripts and so on. In this case I will use two, and at this point I'm ready to go. So let me go here, run all parallel, and it will do everything automatically. Off you go. And now let me go Python plot washer log solver, and there you go. We have our residuals. Okay, so I will let everything recording, and then after this video we move to the next one. So let me go now. Also in this script you will have this one, this directory. Now you use that new plot, and in this directory you have access to some other scripts. So for recall, script 0, and then you have plot all, this one, and it will plot all coefficients now on the fly while you are running. So oops, okay, there you go. And let me go here to show you, actually scripts here, and as you open here you can look what is happening accessing the file. So if you give a different name, change this and so on. So you have a new plot, then this one I think, okay, this two, okay, plot residuals, and this is to compare statistic and so on. And you have also the Python. Okay, so these are the ones in NuPlot to compare statistics. These are the Python scripts and so on. So at this point, well, you showed up from the status I showed you previously that now what you see here, you can also plot it in ParaView. Okay, so you saw that was the final solution, but you can do it on the fly while it's running. There is this live update, so probably we'll throw in some guidelines in the next videos or tips how to do it. But I'm looking for people to help me. Okay, I don't have enough time to do all this stuff, so if somebody wants to do it and create this video, just feel free now to do it, to contribute. This is an open channel and this is our goal, now help people. So this is it. Let's record and, well, let's see how long it takes in this computer, okay, with 2 cores. Okay, we're back and we have a solution. So this word transition from while the simulation was running and the final solution is because Windows installed a day without our consent, so I have to restart everything, but the simulation didn't crash, just was this installation. So everything runs smoothly. At the end, you are going to get these residuals and the forces. We're going to comment a little bit about this. We're going to post-process all the data using ParaView, quantitative, and also a little bit qualitative. Okay, we're going to show you how to do all that in ParaView. And very important now to stress that now we're going to focus into this folder. So remember that here, we enable, we activate some function objects in the control data in OpenFOAM, and we get this output. So we're going to see how to post-process this output, these CFD files, how to manipulate that, but also how to get similar quantities doing the quantitative post-processing in ParaView and comparisons. A reminder, we are using ParaView version 6. Yeah, that's all. Finally, I would like to remind the community that we are growing. We want to grow our community. We just reached 100,000 subscribers, but we want to get to give more to the community, and it takes a lot of effort to do all those videos. So if one of you want to contribute, just contact us. Okay, we accept basically anything related now to the field, to what we work. So please contact us and let's see if we can do a collab. So thank you for your attention and see you in the next videos. Bye.